Okay, today we're going to be talking about how to take something from standard form and put it into factored form. We've been doing that so far, but the only method that we have used is finding the GCF. So today we're going to be looking at a different method. So some polynomials, their factored form is two binomials. So each factor is a binomial. And we're kind of used to seeing this, and we understand how to solve that. So real quickly, we're going to go through the process of putting it into standard form, just to see where it came from. You could use distributive property by saying x times x would be x squared. And we have x times 4, which gives us 4x. And 2 times x, which gives us 2x. So we have 4x and 2x, which gives us 6x. Then we have 2 times 4, which gives us 8. You could also use a table for that with our x plus 2 and our x plus 4, where we know that our 2x's make x squared. Our 4 times our 2 makes 8. And then we have a 2x and a 4x. Either way, we end up with the same answer. So today we're going to be talking about how do you take something that is in this format and put it into factored form. So I just kind of want to note the structure of this. It's a trinomial. It is a second degree trinomial. And I noticed that there's also no number in the front of this. That's called the leading coefficient. So the leading coefficient of this, I'm going to put LC for leading coefficient, is 1. So I know that its factored form is two binomials. And I know that this x squared comes from the first term times the first term, if you kind of think back to FOIL. So I think, what number would I multiply to get x squared? And I know that that's an x and an x. So I kind of split up that x squared. And the last term comes from multiplying these two numbers. So I think the numbers that multiply together to get 8. So we already know from up here that it's 4 and 2 multiply together to get 8. However, also 1 times 8 equals 8. So a lot of times there's a lot of different sets of factors that we could use to get that last number. So the other stipulation or rule that we have to look at is, do they add together to get the middle term? Because we know that that has to happen. We have to combine those two together to get my 6x, or combine those two together to get 6x. So I think, okay, which of these two add together to get 6? And it would be my 4. It's a positive 4 times a positive 2. So if I wanted to go from this standard form to this factored form, that's the process I would follow. We are going to go through some more examples in just a second. Okay, so example 1, we are going to put this into factored form by factoring it. So first we want to notice the structure, that it's a second degree trinomial with a leading coefficient of 1. Because we know it's in that structure, we know that it is going to be a binomial times a binomial. So if we think about what could our first terms be that would multiply times each other to get x squared. So I know that that would be x times x. And then I want to move to my last term and think, what two numbers could I put here that would multiply together to get 16? So I'm going to write down my factors. It could be 1 and 16. It could be 2 and 8, or it could be 4 and 4. But if you remember, my second stipulation was that they have to add together to get the middle term. So I see that 2 times 8 would work, so I'm going to put a positive 2 and a positive 8. So now I have this in factored form. I could check my work by distributing or using FOIL or making a table, where x times x is x squared, x times 8 is 8x, 2 times x is 2x, and 2 times 8 is 16. So if I combined my like terms, x squared plus 10x plus 16. So this is just a self-check to show me that I'm right. This is my answer, the factored form of this trinomial. So we're going to go through number 2 somewhat the same way. I notice it's a second degree trinomial. The leading coefficient is 1. That indicates to me that I'm multiplying two binomials. The first term split up would be a W and a W. The last term split up could be 1 times 28. 2. Okay, so on example 3, I want to factor this. I notice it's a trinomial. It's a second degree trinomial, and the leading coefficient is 1, which tells me that it factors into two binomials. So I kind of use the opposite of FOIL. I think the first terms multiply together to get x squared, so I know that that would be x and x. I know that the last term has to multiply together to get 12, so that gives me a couple of options. 1 times 12, 2 times 6, 3 times 4, and I notice that it has to add together to get another 8, a negative 8. So I look at all of these. None of these are going to add together to get a negative number because they're all positive. However, I know that a negative times a negative also equals a positive. So this could be a negative 1 times a negative 12, a negative 2 times a negative 6, and a negative 3 times a negative 4. All of these sets of factors would equal 12. So now I look and see which one, when I add them together, would equal a negative 8. These, if I added them, would equal a negative 7. If I added those, would equal a negative 8, and if I added those, would equal a negative 13. So I see that this follows both stipulations. If I multiply them together, it equals a positive 12, but if I combine them, it equals a negative 8. So I could check through that and think if I multiplied x times x, I'd get x squared. X times a negative 6 would be a negative 6x. Negative 2 times x, negative 2x, and a negative 2 times a negative 6 would be a positive 12. So again, just self-checking. When I multiply them together, I see that I am right because it is x squared minus 8x plus 12. So here's my answer. Now, we don't always have to go through all of it. Okay, I'm going to have you push pause. Complete these 3 problems in the same spot as you did 1 through 4 and bring them to class tomorrow for us to go through. Now we're going to factor these 2. So same structure, trinomial, second degree, leading coefficient of 1, which tells me that it's going to be 2 binomials. Same thing, this first term x squared would be split into the x and the x. Same thing, we know our last terms need to multiply together to get negative 21. Because it's a negative, that means that one of those numbers is negative. So it could be a negative 1 times 21, or it could be a positive 1 times a negative 21. It could be a negative 3 times a positive 7, or it could be a positive 3 times a negative 7. So we've got some different options here. But we know that when we combine them together, we need them to be a positive 4. So when the answer is positive, that tells us that the bigger number is positive. So here, this answer would end up being a negative 20. So I know that's not the answer. This would end up being a positive 20. That's not the answer. This would end up being a positive 4. And this would end up being a negative 4. So this one is not the answer. So the only option that would work would be taking a -3 times a +7. I could do my self-check. X times x is x squared. X times a +7 is 7x. -3 times x is a -3x. And a -3 times 7 would be a -21. So my first term was correct. Okay, example 6. I see that by the form that we're going to have to factor it into two trinomials. The x squared could be split up into x and x because x times x is x squared. Then I move to the last number and think of what numbers multiply together to get -33. So I think -1 times 33, or 1 times a -33, 3 times a -11, or a -3 times a +11. So I want to get +8, and it looks like these two would add together to get a +8. So I would write a -3 and a +11. I could check myself by multiplying. X times x is x squared. X times 11 is 11x. -3 times x is a -3x. And a -3 times a +11 is a -33, which simplifies to the same thing that I started with. So this would be my polynomial in factored form. So, example 7. A farmer plants a rectangular pumpkin patch. So this would be my rectangular pumpkin patch. In the northeast corner of this square plot of land. This is a square. I don't seem to know how large it is. It says the area of the pumpkin patch is 600 square meters. So this length times this width is 600. So then I can take however big this is. It's S is the whole thing, but if I took off 40, it would equal the length. So I'm going to say S minus 40 times the width, so it looks like S minus 30 is equal to 600. So I know that I can only solve a polynomial if it's in factored form, which this is, and I can only do that when I have the zero product property. But I don't have a zero right here. So I'm actually going to have to multiply this. S times S is S squared, minus 30S, minus 40S, whoopsie, and then negative 40 times a negative 30 is a positive 1200. And then I need to make this side equal 0. So to do that, I'd have to subtract 600 from both sides. And I'm going to subtract it right here. It's like term. So now I have the 0, which means I can use the zero product property. And I have a polynomial on this side. I'm going to go ahead and combine those like terms. Negative 70s plus 600. But this has to be in factored form. So I have to think of what are two numbers that multiply together to get 600, that add together to get a negative 70. I can go ahead and split up my s's and think of these. I could have some easy ones to think of, or 2 and 300, 1 and 600, 3 and 200, 4 and 150, 5 would be 120, 6 would be 100. There's going to be a really long list here. I actually can see though 60 and 10 multiply together to get 600. They add together to get 70. I need a negative 70, so I'm going to make that a negative 60 and negative 10. So those two multiply together to get 600, but add together to get negative 70. So these are my two, and I'm going to do minus 10, minus 60. That means that S, or the length of this, could equal 10 for this factor, or it could equal 60. So I want to look at which one of those would make the most sense. It has to be something that I could subtract 40 from, so it's got to be bigger than 40, it's got to be bigger than 30. So I see that S must equal 60. This one wouldn't make sense. The question asks me, what is the area of this square plot of land? So if S is 60, that means that this is 60. So 60 times 60 would equal 3,600. So the area of my farm is 3,600 square meters, it looks like. And got a few more problems for you to factor. Then, what if the area of the pumpkin patch was 200 instead of 600? So I'm going to give you that picture right here. For you to pause and do.